Hello, I hope you're doing well. I would like to show you some solutions to problems from Section 2.6 homework. I've included both problems from the textbook as well as my math lab. And I have chosen to work a lot of problems, so I may have to do this in two different videos. But we'll just see how the time goes. So let's look at some problems first from the textbook. And I've selected to do number 2. You're given a problem that f of x equal x squared and g of x equal 2x minus 5. And we need to simplify this expression and match it with the expression in group 2. So just recall that f minus g of x is equivalent to f of x minus g of x. So we substitute in our functions to get x squared minus, just be careful here, right, because we've got to subtract off in parentheses this 2x minus 5. And so that means that we need to distribute that negative sign to get x squared minus 2x plus 5. And so that would really correspond then to answer B over here. Okay? Now let's take a look at a few more where we have to either perform the composition or operation. Number 10 is to do g composed with f of x, where f of x is 4x squared minus 2x and g of x is 8x plus 1. So remember that g composed with f of x means to evaluate g at the function f of x. So that is, we're plugging in the function f into the function g. So first off, let's just go through some substitutions. G of f of x is equivalent to g of, now what is f of x? Yes, 4x squared minus 2x, so we put that inside parentheses. Now we look at the rule g and see what that says to do. Rule g says to do 8 times x plus 1. So we have to do 8 times whatever we plug in plus 1. So that simplifies to be 8 times our function rule, 4x squared minus 2x, plus 1. Now just clear parentheses to get 32x squared minus 16x plus 1. Now let's take a look at number 14. F times g of negative 3 is very tempting to want to confuse the composition and multiplication, but just make sure you don't see that little circle there. So that means to do f of negative 3 times g of negative 3. Two ways to do it. I can multiply the functions first, then plug in negative 3, or I can evaluate each function at negative 3 and then multiply. And that's what I've selected to do. So if we do f of negative 3, we get 4 times negative 3 squared minus 2 times negative 3. Applying order of operations gives us 4 times 9 plus 6, or 36 plus 6, which is 42. G of negative 3 is what? Yeah, we have to do 8 times the value we plug in, so 8 times negative 3 plus 1, which is negative 24 plus 1, or negative 23. So now we can multiply those two values together to get 42 times negative 23, which is negative 966. Now the next grouping of problems says to find the sum, difference, and product of the two functions, give the domains of these functions, then find the quotient function and give its domain. And I did not do the composition, but I'll talk through that. So I have done number 22 for you. So f of x is 9 minus 2x, g of x is negative 5x plus 2. So just keep in mind that the sum, difference, and product all have the same domain. Those domains are the intersection of the domain of f with the domain of g. So we'll go ahead and talk about that just for a minute. Since each of these is linear functions, the domain is negative infinity to infinity. Therefore, the intersection of those would be negative infinity to infinity. So the domain of f plus g, the domain of f minus g, and the domain of f times g are all real numbers. So to do f plus g, we simply add 9 minus 2x plus negative 5x plus 2. And when we add, we just combine like terms to get negative 7x plus 11. For f minus g, we have to subtract the two functions. So we have 9 minus 2x minus negative 5x plus 2. And then just be sure to distribute, right? So that's really 9 minus 2x plus 5x minus 2, which combines to be 3x plus 7. And then the product of the two functions we multiply by distributing. So we would get negative 45x plus 18 plus 10x squared minus 4x. So combining like terms, we get 10x squared minus 49x plus 18. Now the quotient is just simply f divided by g. So this is the final function. But the domain, we have to exclude where this denominator is equal to 0. So if I set negative 5x plus 2 equal to 0 and solve that, I get 2/5. So the domain of f over g is all real numbers except for 2/5. Now, the next grouping is to use the graph to evaluate the expression. Whenever I cut these from the textbook, the grids don't really show up, so you need to refer to your textbook pages to see the exact points on the graph. But I have looked at the book whenever I did these. So if we do f plus g of 0, remember what the sum means. It means to evaluate f at 0, evaluate g at 0, and then add those values together. So what does f of 0 mean to do? So if here in number 30, our blue graph is f. F of 0 means to find 0 on the x-axis and go to see where it meets the graph. And it is at 0, 0. So f of 0 is 0. G of 0 is, now looking at the pink graph, when x is 0, where does it meet the graph? The point on the graph is here at 0, 2. So g of 0 would be 2. So their sum is 2. F minus g of negative 1 means to do f of negative 1 minus g of negative 1. Again, f of negative 1, we look at negative 1 on the x. We have to go down to meet the graph, which is at negative 2. Then we subtract off what g of negative 1 is. G of negative 1, we go up, which is 1. So negative 2 minus 1 is negative 3. F times g of 1 is f of 1 times g of 1. So f of 1 is 2. And g of 1 is 1. So our answer is 2. And I think I wrote that incorrectly, didn't I? F of 1 is not 2 there, is it? F of 1 looks to be 1. That should be a 1 times 1. Let me try to correct that. I apologize about that. So 1 times 1 would be 1. Okay. F over g of 2 is f of 2 over g of 2. F of 2 is up here. It looks to be like 4. Okay. Right there. And then g of 2 is going to be a negative 2. So if we do 4 divided by negative 2, we get negative 2. Now you should also be able to do this from a table perspective. So for number 34, we're asked to find f plus g of 2, f minus g of 4, f times g of negative 2, and f over g of 0. So the sum, f plus g of 2, means to do f of 2 plus g of 2. So what does f of 2 mean? We do what? We find 2 in our x. F of 2 is 5. That's what I have here. Plus g of 2, which is 4. So 5 plus 4 is 9. F minus g of 4 simplifies to be f of 4 minus g of 4. So what is f of 4? F of 4 is 0 minus g of 4 is 0. So 0 minus 0 is 0. F times g of negative 2. is f of negative 2 times g of negative 2. So f of negative 2 is negative 4 times g of negative 2 is 2. So their product is negative 8. Then lastly, f over g of 0 is f of 0 over g of 0, which is 8 divided by negative 1, or that should be what? A negative 8. Now, an application problem for you. We have a graph that we're referring to, and it shows in billions of dollars the money spent for general science and for space and other technologies in selected years. G of x represents the dollars spent for general science. S is the dollars spent for space and other technologies. T represents the total expenditures for the two categories. Use a graph to answer the following. Estimate T minus G of 2005. So I'm just going to look at number 42 and figure out what does this result represent. So T of 2005 looks to be like 22.5 minus G of 2005 looks to be about 7.5. So when we subtract those, we get 15. Well, what does this result represent? Well, since T was the total spent for the two categories, and we're subtracting off the general science, T minus G would represent the amount that was spent on space and other technologies for the year 2005. Okay? So I can put this in here. So this is amount spent on space and other technologies for 2005. Now, we're going to use the graphs in a slightly different way now to look at the composition. F composed with G of negative 2. So F composed with G of negative 2 means to do F of G of negative 2. So we have to first find the inside expression. What is G of negative 2? Well, G of negative 2, if we go over to find negative 2 and go up, G of negative 2 is 4. So now what we're going to do with composition, we're going to plug that into the function f. So now we find f of 4, and f of 4 is 2. What about g of f of 1? That would mean to do g of f of 1. So looking now at the function f, when the x value is 1, we get 1. So g of f of 1 is equivalent to finding g of 1. But what is g of 1? Well, it happens to be the same thing as the input, which is 1 again. Now we can do a function composed with itself. F composed with f of 0 is f of 0. Well, f of 0 is 0, right, because that's at the origin. So this is equivalent to then finding f of 0 again, which is still 0. Now doing the same thing except for tables. Oops, I didn't want to do that. To do tables here, we're going to do the same exact thing. To do g of f of 1, we will do g of f of 1. So we look at the table for f, right? And the table for f, f of 1 is 2. So this is equivalent now to finding what? G of 2. So g of 2, now we go to our function g, and g of 2 is 4. So our output there is 4. F composed with g of 4 means to find f of g of 4. Well, if you look at our function g, there is no x value of 4. So since this function is not defined at 4, we cannot find that composition. So that answer would be undefined. What about f composed with f of 3? So that means to do f of 3. So we look at our table. What is f of 3? F of 3 is 6. So now that 6 becomes our input value. So now we have to evaluate f at 6. And f of 6 is 7. I'm going to do one more page and then we'll go to another video. Now we want to find the composition and identify its domain. So I've selected to do number 58, which f of x is 2 minus x, and g of x is 1 over x squared. So f composed with g of x is f of g of x, or what is g of x? 1 over x squared. So we're really finding f of 1 over x squared. Well, the rule for f says to do 2 minus whatever you input. So this output value is 2 minus 1 over x squared. Now to find the domain of the composition, we have to look to the inside function and this final function to look at any restrictions. Well, the only restriction is what value makes the denominator 0, which is 0. So our domain is negative infinity to 0, union 0 to infinity. Now when we do the reverse composition, g composed with f of x, we have to do g of f of x or g of 2 minus x. But what does the function g say to do? It says to do 1 over whatever you input squared. So 1 over 2 minus x squared. So the domain, we take into consideration the inside function and the final function. So the final function, we have to consider where is the denominator 0, and that is where 2 minus x is 0, or where x is 2. So we have to exclude 2 from the domain. So I'm going to stop here and then I'll finish the remaining problems in the second part of this video.